Hello, everybody. Welcome to another very exciting episode of Facet Nation. I am Lucinda.
I am Simon, and this is just a little introduction segment to what we've got coming up for you today. And I would like to present to you Rosie Young, who I came across at the GMA conference. She did a talk about Sunstone to the whole conference, and it went down really well. And I happened to sit next to her at graduation and effectively tapped her up to come on the podcast before the ceremony started. And she kindly accepted the invite. Coming up, we've got an interview with her. She is a lab gemologist. She works at GCS, which is pretty much the best gem lab in the country. She's super, super clever, super lovely. And the chat that we had with her inspired me to go out and buy some gemstones. It's not hard to convince me to do that.
It's not a difficult thing to do, but these gemstones were spectacular.
I don't take much persuading, but she did manage it nonetheless.
And I will say Rosie's chat was so interesting for so many reasons. An amazing authority on Sunstone. So if you love Sunstone, Oregon Sunstone, a great one to listen to. If you're interested in lab gemmology, want to understand how you become a lab gemmologist, what that looks like day to day, also a great one. And also another person who had a career and then decided, you know what, I love gems, I'm going to pursue this. So also very inspiring from that angle.
Yeah, she's a brilliant advocate for education as well in the industry, and she knows far more than us.
Yes. So enjoy, you guys. This is a really great one. We hope that you love it as much as we do.
It's Rosie Young.
Yeah.
Enjoy. Hello and welcome to Facet Nation, a gemmology podcast. My name is Simon.
I'm Lucinda.
And today we have with us a guest, Rosie. Hello.
Hello.
Thanks for joining us today. We are going to have a little chat about what you do in the industry, and we're really excited about it.
Yeah, thanks for having me on.
No worries. Apologies that I'm blue today. I had a bit of an issue with leaving my laptop at work, so I'm on the budget version and I'm blue. So yeah, just bear with us.
You look great, Simon. It's a great color for you.
Thanks very much. The Smurf in the room. Okay, yeah, Rosie. So tell us a little bit about you, your gem story, and what you get up to.
Yeah, absolutely. So my gem story started just over 5 years ago now. So I actually used to be a tax advisor. So I worked at like big accounting firms for a really long time. So like I did people's tax returns, gave them tax advice. And then during the pandemic, I got made redundant. And I was kind of like, if there was ever a time to pivot and do something cool, this is it. So then I basically signed myself up straight away to do the BSc Gemmology degree at Birmingham City University. So I did that. I graduated 2023. And then like a week after my final exam, I flew out to GIA in California. I did the summer internship. And then when I came back to the UK, I moved to London, and then I started my current job at GCS.
Wow, talk about a pivot. That must have taken a lot of courage.
Big changes, yeah.
So did you live near Birmingham then?
So I actually lived in Manchester, and I had to commute down to Birmingham, which was a little bit brutal. But made it work.
Wow. Okay. So what made you? Have you always liked gems? Like why or gemmology or just science in general?
Yeah, I have always liked gems. Like I always loved gems as a kid. You know, I was always collecting, you know, kind of little polished bits of quartz or, you know, whatever you can get your hands on, you know, when you're that kind of age. And I think I kind of had this realization of like, why can't I do something as an adult that I enjoyed and thought was cool when I was a kid? And you know, it's worked out really well. Yeah, I never thought I'd have a job that I enjoyed this much. So it's really been an amazing journey.
That is the dream, really, isn't it? Doing something you actually want to do.
Yeah.
The tax advising wasn't as interesting, I take it.
No. I mean, none of it's shiny, is it? It's just not as exciting.
True story.
Yeah.
What was your experience on the BSc like? Because I feel like ours is kind of a short course in comparison. So how did you find it in terms of rigor and kind of focus and what was being asked of you?
Yeah, it was. I really enjoyed it, actually. and made a lot of great friends doing that course as well. So that's been really valuable. But yeah, it was really interesting. The first year you sort of start out just looking at like say like a different mineral or different gem material each week. And you learn all of your basic testing. And then in the second and third years, you do some kind of like more specific modules. Like we had a module just about jade, we had one about organic gemstones, and then you move on to learning some of the advanced testing. And that kind of set me up a bit for working in the lab, because it gave me at least a basis of some of the science that I'd need to do that and how to use some of the equipment.
Yeah, the stuff that scares us, the ramen.
Yeah.
Is it?
Oh, the ramen's the best. Like
is it right that if you do the GMA diploma, you can sort of tack on a year at Birmingham and then get a degree qualification?
Yes, you can. Yeah. So if you're FGA DGA, then you can just jump straight in.
You have to do both.
Do the third year. I think, though I don't know exactly. I think there is also an option to just skip the first year.
Okay.
And you can do 2 years. Or yeah, like I've known a few people who have had like FGA DGA and then they've come in for the third year.
And the third year looks the same as what you did.
So third year looks the same. So I think it's initially a bit of catching up in some regards. But yeah, like I know a few people who have done that really successfully. So it's definitely an option.
So you went to GIA and did the GG?
So I did a research internship.
Okay.
Tell us about that. What were you looking at?
Sunstones.
Oh, yes, of course.
So,
which is part of why we're here.
We're getting
so I got really lucky with that opportunity, because basically whilst I was doing my degree for my final research project, I did a project on sunstones, and I was kind of like, I really just want to keep looking at more sunstones. And so I was really fortunate to get the opportunity to go to GIA, which was absolutely amazing. Everyone over there is wonderful. It's an amazing team, and it's amazing facilities as well. I got to use all of their equipment, but also like they let me look for samples in like the GIA museum collection and some of the research collections. Like if I wanted to look at Oregon sunstones, they had some that they'd previously gone out and got fresh from the mines. So it really was kind of like everything was there. It was really great.
Wow. So how does GMA fit into this? Because you were at our graduation.
Yes. So I kind of did the opposite way round of things. So instead of doing the FGA DGA, then doing the degree to top up, I basically said to GMA, can I do the opposite? Like I've got my degree, can I just show up and do the exams? Right. So this year I did my FGA, my DGA, and I did the FEIG European Gemologist as well.
Okay. Yeah, I've thought about doing that.
It's good actually. I recommend it.
Okay, it's just a couple of days with Pat Daly, basically, isn't it?
Yeah. You have I think it was like 3 days of training. Then you have a day of exam, so you have a theory and a practical. But yeah, it's really good actually. I really enjoyed doing it.
The exam's pretty long.
The exam's multiple choice.
Okay, but it's long.
The practical's long, but that's kind of good because you're not rushing it. Because I found with the FGA one, like, because I hadn't rehearsed doing it, I then got a bit panicked because I was kind of like, this is taking much longer than I thought it would take, and I was rushing at the end. Whereas with the FEIG one, like, I was chill. I left half an hour early. Like, I didn't rush anything. Right. So it's kind of like it's harder because you have more stones, but it's also easier because you have more time and you get a bit more equipment as well. Like you can do specific gravity, for example, and you get a bit more information about the stones. So it's it tests you in a slightly different way, which I think is good experience.
Okay, so you were at our graduation, and from what I can tell, you did rather well in the exam.
It went okay, yeah.
Because you got an award, didn't you?
Yes, I did. Yeah, I got the Theory Prize Award.
Amazing! Congratulations on that.
Yeah. Well, congratulations to you guys as well.
Well, yeah, it was a slog, wasn't it, Lucinda?
Yeah,
we made it.
Yeah, we did, just about. So, yeah, you now work for a Gem Lab.
Yes, I do. Yeah, so the last 2 years, I've been working at GCS Lab, over on Bond Street in London.
Okay, tell us more about that.
Yeah, so we're the UK's leading independent gemmological laboratory. So we're a reasonably small team. So there's three of us on the gemmology side, and then my colleague Cami is kind of like the office manager. So she sort of like manages the day-to-day, manages like the client side of the lab, and then we have one other person who sort of does a bit of both part-time. So it's a nice team. We've got various different bits of equipment, and we see a lot of really awesome stones, and we get to spend a lot of time on the microscope looking at all the inclusions. So it's a really great job.
Nice. And what would you say makes someone particularly well suited for lab gemology work as opposed to more of what Simon and I do, which is pouncing around a sales floor?
I think, yeah, it depends on what your skill set is. Like for me, I don't think I would be good at selling things, and like I also don't really know the value of anything. So it
Okay.
kind of, yeah, it's different skills, but I found that like the science is really enjoyable. So if you like just like finding out more and more, like say like when you're studying, you learn about like which elements cause color. And if you like the idea of being able to put your gem on a machine and it actually detects those elements for you and you can see them, or sort of like interpreting a graph to find out, is your sapphire heated or whatever it might be. I think if that appeals to you, then it's very, very interesting work.
I
And what's
think
the
that probably
day-to-day
does
like?
appeal to me.
Well, yeah,
Yeah.
Simon, I think you'd be a great lab gemologist. I really do. The way how your eyes shine when we talk about light and optics.
Yeah.
Science.
So you clock in, it's the morning. So how many stones are you looking at? Is there a constant flow of stones? Like what's the day-to-day like?
Yeah, so there's always a constant flow of stones. We have a queue of stones that are waiting to be checked, depending on kind of like the order that they got submitted. Last year we did just over 4,000 items, so there's quite a lot coming in. Uh, and quite a lot of it is set jewelry. So some of it will just be, say, like a loose sapphire. We test the sapphire, that's it. Or it could be, say, like a necklace of 100 sapphires. And we're not going to test every single one, but it can be quite variable, like the amount of work that goes into each piece that we look at. And quite a lot of it actually is antiques that we're testing. So we see a lot of, say, like Victorian jewelry, for example.
Cool.
And they're being submitted to you to provide sort of documentation for them.
Yes, yeah. So we produce certificates. So we'll identify the material, and then depending on what it is, if it's something where we can do this, we'll also say, has it been treated? How has it been treated? And in a lot of cases, we can give an opinion on where we think it was mined. So, for example, we do this for corundum and emeralds most often, but we can do some other gem materials like Paraiba tourmaline, for example.
Yeah. Okay. And what's the process for determining those things, like your treatments and your localities and things like that?
So for the localities, a lot of it we do based on the trace element chemistry, because this will sort of vary depending on the environment where the gemstone formed. So say for example in sapphires we'd see different levels of iron and titanium, perhaps from different localities, different amounts of gallium. And yeah, so there's published data for each gemstone and each locality, and we sort of compare it to that. And then also, like, I've made a big spreadsheet of like all our past data, so we can compare, say, like if a sapphire has this chemistry and we think it looks like it might be cashmere, is it similar to other cashmere sapphires we've had
Okay,
chemistry
fine.
wise? So we can
And
sort of match up from that point of view.
and is that data that you've compiled yourselves within the lab, or are you borrowing it from somebody else?
It's a bit of both. So we compile our own data, but a lot of the data we'll use will be, say, from articles published by other labs. So GIA have some really excellent articles about origin determination, which I think are in the winter 2019 edition of Gems in Gemmology. And there's quite a lot of others out there as well. So we try to take a mix, because obviously we want as much data as we can possibly get, so that we can get the best answers for our clients.
So cool.
Yeah, amazing. And getting the data, what lab equipment are you using to do that?
Yeah, so for the chemical analysis, we have an XRF. Basically, it emits some X-rays into the gemstone, which then sort of sends some X-rays back out, and then it detects what exact wavelengths are coming back, and that tells us which elements are in there. So it helps us with the origin determination, but also it's useful for gem ID, because say if you've got a sapphire that's corundum, which is aluminium oxide, so you know you're going to detect aluminium. So for a sapphire, obviously we'd know what it was anyway, but if we have something more unusual, it's quite good to know the chemistry to help figure that out. Or say with garnets, we can figure out exactly what kind of garnet it is based on what the compositional elements are. So yes, we have XRF. We have also an X-ray, which we use for pearls. So if we want to know if our pearls are natural or cultured, we can X-ray it and actually see the beads inside the cultured pearls. So that's a lot of fun.
So fun.
And then we have the Raman, which you mentioned earlier. So this we use for mineral ID. It's very quick, it's very handy, and that just basically gives us an answer of what mineral we're looking at. We also use it a bit in diamonds as well, as part of our diamond testing. We have the UV-Vis NAR, and this is basically, like the handheld spectroscope. It's kind of like that on steroids. So kind of like a digital version of it. So like when I first started studying, they'd sort of say like, oh, look in your spectroscope, you can see like the 653 line in zircon. And I was like, well, how does anyone know? Like, am I supposed to be like guessing a number based on just looking at a rainbow? But this is the machine that actually tells you. And it basically produces a graph where the peaks are on the graph. It gives you a number in nanometers, and you can see where there's an absorption. So we use it doing our origin determination on sapphires and emeralds. Also, it does some other useful stuff, like we can tell the cause of colour. So if we're looking at a blue tourmaline, we can see, is the colour coming from copper? Is it coming from iron? So is it periba or is it indicolite? And also with cobalt spinels, we can tell, is the colour coming from cobalt or is it not? So there's all kinds of useful things we can do with that. And then our other main bit of equipment is the FTIR, and this lets us look at absorptions in the infrared. And so one of the things we use this for is detecting oils and resins. Say in emeralds, often oiled or resin impregnated. Same with jade. So this will enable us to pick this up, and we can also use it to sometimes discover if rubies and sapphires are heat treated. And we can use it as well for diamond type. So we can see, is there nitrogen in there? How is the nitrogen aggregated? And also sometimes diamond treatments as well we can detect with it.
Do you produce diamond certificates as well?
We do, yes. Yeah, so we'll grade diamonds as well, and we plot the inclusions. Yeah.
Is there a piece of this equipment that you particularly enjoy using or find particularly satisfying when it gives you a result? So do you especially like finding out if an emerald's been oiled, or what kind of calls to you?
Ooh, I think I quite like doing the chemical analysis. But yeah, I mean, to be honest, all of it is fun. I think I quite like it when I get a surprising result, because often you see the same stuff again and again day to day, and it's still enjoyable. But then sometimes you get a stone that just surprises you, and that's always fun to see where it takes you.
Yeah.
Some of
I was going to ask.
Go on. Sorry, I was just going to say some of the readings for things like tourmaline can be nuts, can't they? There's all manner of stuff.
Yeah, there's so much in there.
Small percentages of all manner of stuff. That the list must be enormous.
Yeah, because as well, we're sort of typing it up, and when it's the sapphire, I'm like, okay, that's easy. We've got our aluminium, bit of iron, bit of titanium, and then when it's the tourmalines, I'm like, oh, I've got to write all this out.
Here we go.
Yeah.
Does it work a little bit like retail? That what I notice a lot is that stones come in waves, so people will be really into yellow diamonds and they'll be really into cornflower blue sapphires and whatever. As styles change and tastes change, does what people are submitting for evaluation change? Or is it mostly, or not valuation, identification? Or is it kind of the constants of emerald, ruby, sapphire, diamond?
I think we're maybe a bit unique, as probably a lot of labs are getting more of a taste of what's popular in the market and what's the freshly new material out. Whereas, because I think we get so many antiques that I don't think we're seeing a lot of trends that might well be out there, and maybe somewhere like GIA would be seeing those trends, but I think we're a bit sheltered from it because we're mostly seeing sort of the Sri Lankan sapphires, Colombian emeralds, Burmese rubies,
the stuff nobody else gets to see these days. Yeah. Jealous.
So in terms of gemstones themselves, I suppose I'm going to ask two questions here. What's your favorite gemstone, which I think we know the answer already.
Yep.
And the other question is, like, what is a favorite gem that's come in the lab and why?
Oh, so my favorite gemstone is Sunstone, which I think is probably gonna not surprise anyone who knows me. My all-time favorite is something called Rainbow Lattice Sunstone, which I saw a picture of once and then instantly became obsessed with it. And that was kind of like my Sunstone gateway drug, just because it's really cool. There's nothing else like it. It's got this really interesting pattern of inclusions where it's kind of like these rainbow blades that cross over each other and then these perfect equilateral triangles. And it looks kind of like an 80s disco or something inside. It's amazing. But it only comes from this one mine in Australia, and that's it.
I bet that is good under the microscope.
Oh yeah, it's really awesome. Like, you have to get the light right, but once you do, you get all these rainbow colors suddenly reflecting back at you, and it's stunning.
And you've seen this under the microscope. You've had it like...
Yeah, I've got a bunch of them, and I got to look at some more when I was at GIA as well. So I've got some nice pictures. But yeah, even with the naked eye, because the inclusions are quite big, you can actually see it even without a loupe.
So
Amazing.
cool.
Yeah.
And is there a stone that's come across your desk that you've been particularly drawn to or like excited to unpack a little bit? Is there anything that springs to mind?
I'm trying to think, actually. Like, we do see a lot of cool stuff, so it's hard to narrow it down.
It's hard to, yeah.
Yeah, we have had this year a couple of bigger cashmere sapphires, and they're just always amazing to see. Like, just so like velvety, and it's always exciting when you get one, especially if you have no idea that it's gonna be a cashmere, and then we'll go on the microscope and look at it, and usually one of us will sort of exclaim like, "Oh shit, this one's a cashmere!" Like, how exciting!
Guys, come over.
Yeah.
You're queuing up to look in the microscope.
Yeah. So yeah, we always love that. That doesn't get old.
Where are those stones coming from? Like the cashmere things, if you're allowed to tell us, like what sort of people are giving you them?
It's a bit of a mix. I mean, a lot of our clients are in the trade, so they're buying and selling. Sometimes they know they've bought a cashmere and that's why they've brought it to us. Other times they have no idea and it's a very pleasant surprise when we tell them.
I can imagine. Gosh, jackpot.
Yeah, like what? Like where have you bought that? You're like, oh, love, that looks quite nice. I'm going to buy that, and then let's get it tested. Bingo. Because like the value, the difference in the value, just by being able to say that about it.
It's astronomical, isn't it? Yeah.
Absolutely extraordinary. Yeah. Sorry, I don't know what that was.
People just have them in safes, though, don't they? In this country, in America, it doesn't really work that way.
Yeah.
But here, like someone will just inherit something and nobody knew what it was, and it's a cashmere sapphire someone's great grandpa brought back. It's wild. It's so cool.
Yeah.
So your favorite gemstone is Sunstone, and from what I understand, you have done some pretty extensive research into Sunstone.
Yes.
So you decided to do that because you love Sunstone, I assume.
Basically, yeah.
Okay. And then
we all follow our passions, Simon.
Yeah. So tell us a bit about the research.
Yeah. So I initially started out looking at sunstones with hematite inclusions. So the rainbow lattice I was talking about before, that has hematite inclusions, but it also has magnetite inclusions. It's basically, it's iron oxide. Some of them start as magnetite, and then with weathering, they become hematite. And then your classic, like your sort of like orangey looking cabochon sunstones with like the hexagonal hematite platelets. So I was looking at a bunch of those, and sort of trying to find out like where in the world were they coming from, were there any distinguishing features, like what other minerals might be in there as inclusions. But then when I was at GIA, I also got really into Oregon sunstone, and then I became a little bit Oregon sunstone obsessed as well, because I think I'd underestimated it before, and the more I learned about it, the more I learned that it was really, really interesting. And there's a few things that kind of like get explained in passing, like, oh, like the color is from copper and the inclusions are copper, done. But then it's like the more you study it, the more you realize how fascinating it is, and there's quite a lot to it. So yeah, then I kind of got into a bit of an Oregon sunstone rabbit hole, really, as well. So yeah, now I love all of the sunstones equally, I think.
So for people that are listening to us that might not know sort of what a sunstone is, or the difference between an Oregon sunstone and a hematite sunstone.
Yeah.
Could you tell us a bit about that? Because they're feldspars, aren't they?
Yeah, so all of them are feldspars. So to be a sunstone, it has to be a feldspar with some kind of phenomenal inclusion. Confusingly, sunstones, some of them are also moonstones because the two effects, so the adulorescent effect in moonstone and the eventurescence of sunstone, they're not mutually exclusive. So you can have both. Some of the Australian ones, they actually trademarked the name eclipsite to be like, it's like sun and moon at once, which
That's
I
a
thought was
good
kind of
name.
fun. Yeah.
I like that.
So you can get all kinds, really. A lot of information about sunstones will just say like, oh, they're a ligoclase feldspar and leave it at that. But actually, there can be a whole range of different compositions. So with feldspars, you've got potassium feldspar, which is orthoclase, and then you've got the plagioclase series, which goes from sodium to calcium. So you can have orthoclase sunstones, and you can have them from kind of like different areas of the sort of plagioclase spectrum. So Oregon Sunstone is labradorite, which basically means it's got quite a high calcium content. And then most of the sunstones with hematite in, so the sort of rainbow hexagonal platelets, those are usually oligoclase, which is higher in sodium. But yeah, it's quite variable, and feldspars are really complicated, and I think they're actually not really taught that much in gemmology. But yeah, it's one of these where once you get into it, you're like, oh, there's actually a lot going on, even just figuring out what feldspars are before I figure out like what's going on with the sunstones. And once I started studying it, I kind of realized that there just wasn't actually very much information out there about sunstones at all. Because I was sort of like, okay, I'm getting into sunstones. I just want to read an article that tells me about all the different sunstones. And I realized that such a thing doesn't really exist.
Which is wild, really.
Yeah. And because even in, say, like the GMA notes, there's like a few paragraphs, which doesn't really summarize that much of it. I guess they're not kind of like, they're not a big priority stone for a lot of people. But yeah, I want to spread the word, I guess, about
stand up
sunstones.
justice for sunstones.
Yeah, so more people appreciate them.
We have a lot of slogans along those lines, justice for all manner of things. So Lucinda and I think in an episode that just came out recently, we refer to the hematite sunstones as having a spangle and the copper sunstones having a shimmer. Would you agree with that?
I actually would agree with that. Yeah, I think that.
Thank God. Okay.
Okay, that's good. I don't want to spread any misinformation. As long as you approve with that terminology, then we'll stick to that. What was I going to ask you next? Where do they come from?
So Oregon Sunstone comes from Oregon, which is probably a surprise to no one. So Oregon, which is the state north of California on the west coast of the USA. And then with the hematite sunstones, the lattice sunstones, so the rainbow lattice sunstone is Australian. There's also quite similar material coming out of Tanzania, which it is possible to tell the difference, but some of it looks quite similar. So to the untrained eye, you might mistake it for the Australian rainbow lattice sunstone. But yeah, there's a bunch of different very cool and interesting sunstones coming out of Tanzania at the moment. And then in terms of
there's
otherwise,
a bunch of everything coming out of Tanzania.
Yeah, I think Tanzania, they're finding a lot of cool stuff. But yeah, in terms of general like hematite sunstones, like India is pretty big. But yeah, there's all sorts of places, like even like Norway has some. I think Madagascar, Malawi. There's a whole bunch of them all over the place.
Do you feel particularly attached to certain localities? Like, for example, you'll always pick an Australian sunstone over something else, or are you're in it for the material itself?
I think I'm mostly in it for the material, but then I guess some localities are special. Like, there's nothing else that's quite like the Australian one. So I suppose because the material there is better,
just so unique,
I favour it for that reason. Yeah.
Nice.
So the Oregon sunstone tends to be the ones with the copper inclusions.
Yeah.
So when you say sort of Oregon sunstone, you tend to think it has a shimmer versus a spangle. Is there anywhere else where you get shimmery sunstones?
Yes, so there's one other place which has copper-bearing sunstones, which is Ethiopia. There's not a lot of this in the market. It's quite difficult to find, but there's two articles published about it, one in Journal of Gemmology and another in Gems and Gemmology. But yeah, it's quite difficult to find. I think maybe because of the civil war in Ethiopia. There's not a lot of it being mined, and it's not very easy to get. But yeah, that's the other location for copper bearing sunstones. There are some others as well, I think, in Mexico, but they're just kind of pale yellow, whereas the Oregon sunstone, it has red and green as well, and it's more attractive.
So this is a question that I asked you at graduation. If Oregon sunstone has copper and Ethiopian sunstone has copper, but we define copper-bearing sunstone as being from Oregon and calling it Oregon sunstone, what are we calling Ethiopian sunstone?
Yes, so I've had to think about it to try and find a good name. And then I gave up and asked my friend Ella to do it for me. And she came up with, which I think is quite good, sunstones from afar, because they're from the Afar region of Ethiopia, which is like a very like volcanically active region. It's on like it's where like 3 tectonic rifts meet. So there's all kinds going on like geologically over there. But it makes them sound really mysterious, like from afar.
Yeah.
But they are literally from the place called Afar.
That's really good. I wasn't expecting you to. I wasn't expecting you to do so well.
I thought we were going copper bearing sunstone on that one.
Yeah, I thought you were going to be like
Ethiopian copper bearing sunstone.
I thought you were going to be like, listen, Simon, you sent me this challenge, and honestly,
yeah, I've come here to disappoint you.
Yeah, I'm actually super impressed. Egg yolks. Why am I mentioning egg yolks?
I imagine you're mentioning egg yolks because so I did a presentation about Oregon sunstone at the GEMA conference, and one of the things I was trying to explain is the color zoning in Oregon sunstone, which is really unusual. So the outside of the crystal is colorless, and then the middle is usually red, and they've laid out a bit like an egg, like you've got like this red yolk and this colorless outside. And then I was kind of setting out to prove that the shape of the coloured part actually follows the shape of the rough. And even if you've got this weird shaped broken chunk, you'll still have a red zone that's the same shape. So say it's like if you had a triangular egg, would you have a round yolk or a triangular yolk? If that makes any sense explaining it.
It does.
So I had these strange PowerPoint slides of these like weird AI generated eggs that maybe gave people breakfast nightmares. Like different eggs with different strange yolks. But hopefully it got the point across. And the reason that you get this strange colour zoning is it's actually a kind of natural diffusion is taking place. And as the sunstones are cooling, the copper's actually diffusing out of them, and that gives us this colourless zone at the edge which doesn't have any copper in it.
I was going to say, so the red yolk, which is sort of following the outer outline, is the copper.
Yes.
And it's sort of like trying to get out, basically.
Yeah, so when the crystal is hot enough, like the copper's dissolved, everyone's having a good time. Once it cools down, it's no longer fun for the copper anymore.
We're leaving the party.
Yeah, so it wants out. So if it can get out of the party, it will. If not, then it has to basically precipitate into either like the copper schiller or these kind of like nanoparticles, like colloidal copper particles, which give it the red color or the green color that you sometimes get.
It's kind of biblical.
Yes, it's quite epic.
And I
get
guess
out while you can.
Perfect sense as to why it sort of follows the outline then, doesn't it? Because it's sort of like just going straight out that way, and it gets to a point where it's stopped being able to get out.
Yeah,
stuck. It's kind of like on a plane, you go for the nearest exit. That's what the copper's doing.
Here and here and here. Yeah. You experimented with some heat treatment yourself, didn't you?
Yeah, so I was lucky to get the chance to do some copper diffusion experiments. So one of the big problems in the marketplace is diffusion-treated andesine. So andesine is just a different composition of plagioclase feldspar. And people had been diffusion treating this and passing it off as a new kind of natural sunstone from various different places. So if you hear of sunstone from the Congo or like China, Tibet, this is probably the diffusion-treated stuff. And there's quite a lot of it out there, and it's still being sold. But it was a big controversy around sort of like 2008, 2010 when this first came out, and people were trying to prove that this wasn't really a natural stone, which is hard to do when like this treatment hasn't been done before and you've never seen it. So there's there's a lot of the Andesine out there. So I was doing some copper diffusion experiments basically to make this myself. So I had a few different colorless crystals of Andesine feldspar, and then some colorless crystals from one of the Oregon Sunstone mines, and basically whacked them into a furnace with some copper powder. But then after a couple of tries, they came out bright red, and it was so exciting.
And what sort of temperatures are we talking?
So there's quite a specific temperature range, because too hot and your feldspar will start to melt, and then the whole thing is ruined. But
Right.
if it's not hot enough, then basically the copper's not going to do anything. So I think the ideal range is about sort of like 1100 to 1250 degrees, which is the kind of temperature we'd be expecting for the basaltic lavas which we're finding the crystals in nature. So it kind of matches up quite well to the natural environment that we know that they come from.
Interesting.
And how deep does it go?
I, as in like into the ground.
No, into the
stone.
Into the
Into
stone.
the stone.
Yeah. How deep are we?
Talking
how far
surface
are
and
we?
lattice diffusion.
Yeah,
Is that
how
what you're
far are we
asking,
getting
Simon?
in?
You can get all the way in. So it depends how long you diffuse them for. So I did mine for like 48 hours, and then it had got like most of the way through.
Okay.
So I think if you did it for say 3 days or so heating, you'd probably get
You reckon the whole thing's
like
going
full diffusion all the way. I feel like a lot of this conversation has been a bit like that's what she said, you know.
All the way in?
Yeah. It got part of the way in.
That's so interesting. And does that, I mean, it's always so interesting to me when people spend like so much time and money developing treatments for stones. Like they must have really thought about turning this andesine into something for a long time.
Yeah. And then it's like, how do you discover that you can do that in the first place? Because it's kind of like, it's known that there's a natural diffusion, or it's theorized, but it's not something that's talked about all the time. So I don't know how people kind of originally came up with this idea, or if it was just like, let's just keep throwing stuff in a furnace and see what happens. But yeah.
YOLO. It's so cool to be able to do it yourself, though.
Yeah, it was really exciting.
Why are they doing it with andesine? Why are they doing it with andesine as opposed to colorless sunstone, if you like?
Yeah, so the Oregon Sunstone is labradorite composition, even though it doesn't look like what we would think of as labradorite. It doesn't have any labradorescence. But andesine is
labradorite, kind of, you mean where it sits on the scale of
where it sits on the plagioclase range. So labradorite is basically next to andesine. Just it has a bit more calcium rather than sodium. But the good like big crystals of high calcium feldspar are actually not that common. So I think it's just that andesine was what was available.
Yeah, and it was a useful thing to replicate. Yeah, because I think
because it's pretty similar.
If you had like even less calcium in it than that, it would melt too easily.
Okay.
So something like albite or a ligoclase, sort of like the far end of the plagioclase series.
The sodium end.
Yeah, the sodium end. It wouldn't be so easy to treat because you've got a higher risk of melting. But yeah, the labradorite crystals are harder to find. So I think andesine was just like, it's available, it works.
Sweet spot. Yeah. We can still cook it pretty high temperature, shovel that copper in, and it's kind of doing a pretty good job. Because it's
as Rosie says, it only takes 2 days, right?
It's really hard to detect though, right?
It can be, yeah. Like some of them are obvious, like as soon as you look at it you'd be suspicious, but a lot of them aren't. They can look really quite convincingly like Oregon Sunstone. I think some Oregon Sunstones, like you'd be able to tell because they have huge copper platelets and you don't really get such like big particles of the copper schiller in the diffusion-treated. But if you had an Oregon Sunstone with very small copper platelets, they wouldn't be that different to the size of the ones in the andesine. And as some of them are quite convincing, like I probably need a microscope to be able to tell you. So yeah, it really can look quite good.
And when you're looking under the microscope, what are you looking for?
So I'd be looking for unusual color zoning, which can be different. So one of the classic ones I always tell people about is watermelon and reverse watermelon. So something that's quite common in Oregon Sunstone is the watermelon color zoning, as we're familiar with from, say, tourmaline, where you have the red in the middle and like a green rim around the outside. And this is all part of the yolk. You still have a big colorless area outside of that. But then in the diffusion treated, you sometimes get it the other way around. So you get what would be this really weird, unappetizing watermelon with green on the inside and red on the outside. So if you see that, that's a big red flag. The smaller platelets of copper also, you'll have an area with the copper schiller, and then the area around it will be colorless. And you can get this a little bit in natural Oregon Sunstone, but it's quite subtle. If it's sharp, like you've got bright red, and then you've got this colorless zone, and then you've got a band of copper schiller, that to me would be suggesting diffusion treated andesine. And sometimes you just get like unusual features because I think the copper is coming in so fast compared to what you might see in nature, where there's a lot more heating and cooling time, perhaps. You can get just like some strange arrangements of the copper, which would kind of be a bit of a giveaway as well.
So the copper, how does the copper normally arrange itself in Sunstone?
Yeah, so in Oregon Sunstone, it usually has this kind of banded appearance. So it really favors one particular plane, which is, it's like the plane that it twins on, but it's also a cleavage plane. And so usually, if you look at it from one angle, you'll sort of see it everywhere. Then if you turn the stone, it will look really, really stripy, and you'll see these like really clear layers. And that's
because of the twinning, basically.
Yeah, that's just like kind of, I guess, where it's easier for big platelets to form in the structure of the feldspar. It's definitely, for whatever reason, I don't know if it's the cleavage or if it's the twinning, but whatever's happening on that plane, the copper platelets love it there. So they're always kind of going to favor that sort of like stripy layered formation. And you do get this in the andesine, but it just doesn't quite look the same. And sometimes in the Oregon Sunstone, you can get sort of like almost like long fine wires of copper. And in the andesine, you get these like really irregular versions of it where it's just not like a neat straight line. You've just kind of got bits of copper going everywhere because it's just sort of diffusing fast and just kind of making copper platelets wherever it can.
Copper platelets randomly oriented in a material. That leads me to mention my most hated of gemstones, which isn't even really a gemstone, goldstone. What do you make of that?
Yeah, I mean, goldstone is kind of fun on a microscope because you can see all these sort of little sort of triangular copper crystals. But do I enjoy it otherwise? No.
No. Okay, good. We're all
let the children live, Simon.
Yeah, I'm not going to tell you about my beloved goldstone ring or anything. No, don't worry.
Okay, good. I've got big issue with goldstone.
It's got beef.
Yeah,
it's got beef.
Yeah, I think that's been absolutely amazing. Is there anything else you want to ask, Lucinda?
This is just like because I get very attached to gem species, and when I see people wearing them in a way that's maybe not best for the stone itself, I get upset. Do you feel that way about sunstone? Like when you see big sunstones in rings and stuff, are you glad that sunstone is having a moment in the sun, so to speak, or do you ever get a little protective over it when you see it in the world?
I guess I don't think I see it often enough. So if I did see someone with a sunstone ring, then yeah, I mean the moment in the sun phrasing is beautiful, but yeah, I would just be happy for it. I'd be like, it's out and about, everyone can enjoy it, like somebody else is appreciating sunstones, it's not just me doing it on my own.
Amazing. Well, everybody go up, get some sunstone. Where do you recommend that, what localities would you recommend people look at to get hooked on sunstone?
I mean, definitely I would recommend Googling the Australian rainbow lattice just because like you won't see anything else like it. And yeah, I mean, Oregon Sunstone is always amazing. Like if you get it on the microscope, you can just kind of get lost in there.
Where can you buy it?
So actually, in both those cases, like some of the miners they'll go to say like the Tucson gem shows. So you can actually buy it direct. The Rainbow Lattice mine, they'll sell it direct over the internet as well.
Oh, cool. So Simon's going to go stock up right after this, I swear.
Go shopping. He's
going to be texting me tomorrow with his new Rainbow Lattice
sunstone purchases. Yeah. Well, yeah, there's so many really interesting Tanzanian sunstones, which are sort of all over, say like Etsy, for example.
Okay.
And every time I look for them, there seems to be something new that's slightly different. There's stuff like, for example, meteor shower sunstone, which has a lot of sort of like rainbow parallel lines. There's something called purple haze sunstone. There's something called Malawi moonstone, which I think is maybe actually a sunstone, and it's also apparently from Tanzania.
I'm writing that down.
Yeah, there's all sorts
It's a
going on.
wild world. There's a lot to explore
Yeah,
with these
there's
sunstones,
always
isn't
something
there?
new to discover with sunstones.
So
That's so cool.
So when we finish this and I do start Googling these things, I'm going to Etsy and searching for Tanzanian sunstone, purple haze sunstone. Okay.
Malawi moonstone. I'll take Malawi
moonstone as well.
Yeah.
Wow.
You're going to have a good time with this.
Okay.
Amazing.
Yeah. That's me for the next hour or two.
Rosie, is there anything about your journey in gemmology or about Sunstone that we haven't touched on that you think it's important people know?
I don't think anything in particular. I mean, I can talk about sunstones for hours, but I appreciate other people are only so interested in feldspars. So yeah, it's nice to be able to come on here and tell people a bit about them anyway.
No, it's been absolutely our pleasure. Go on, Simon.
Do you like any of the other feldspars?
Not as much. I mean, everyone I think can enjoy similar radiescence, right? Like that's always lovely to see, especially when you get different colors, kind of like the whole spectralite thing. That's always amazing. Or those, there's more and more of these like rainbow moonstones, sort of like technically labradorite, but transparent. Those are incredible. Think like they're really having a moment. I'm seeing more and more
being
of them,
faceted and looking
crazy.
really amazing.
Like the faceted ones are gorgeous. So yeah, I think they've definitely got to be up there.
Amazing.
Everybody, email us. Tell us your favorite feldspars.
We'll do a poll.
Yeah, I'd love to see the results.
Yeah.
Amazing. Well, thank you so much, Rosie. This has been so interesting. Simon and I are now going to go into separate sunstone holes.
Yeah.
Literally, that's what I'm going to do for the next hour.
Yeah. Well, enjoy.
Thanks.
Thank you. And thank you so much for taking the time to speak with us. It's been a real joy.
Yeah, well, no, thanks for having me on. It was great talking to you guys.
Just before you go, like we said right at the start, you work for GCS. If anyone wants to send their gemstones or anything to you for you to inspect them, how do they go about doing that?
Yeah, so you can bring them to us in person. Say we're on Bond Street in London. We're open 9:30 to 4:30 Monday to Friday. Or you can post to us, send with a courier. We recommend just send us an email first if you're going to. So obviously we need to expect it, and we can also confirm that it is something we can test. Because sometimes people want to send us all sorts of stuff, say like big mineral specimens, and we can't test those. Like they won't fit in our equipment. Obviously we're sort of set up for small gem items. So yeah, I'd recommend send us an email with what you have, and then we can go from there.
Brilliant.
And are there any personal projects or social media platforms that you'd like to tell I almost said readers, our listeners about?
Yeah. I guess, I can give my Instagram, which is Gemstone Science, at Gemstone Science. Or the one for the lab is, I think, at GCS Lab.
Awesome. Well, thank you so much, Rosie.
Great. Yeah, thank you.
Such a great chat with Rosie. Honestly, I left so inspired, and we both immediately started just shopping.
Yeah, I genuinely hit stop on record and then went and sat on the sofa and looked at Sunstone and like meteor shower sunstone and the rainbow lattice sunstone like for ages and ages and ages.
And you bought something, right?
Yeah, I bought some meteor shower sunstone.
Gorgeous.
It's coming from some far-flung land, so it's taking bloody ages to arrive. But I'll let you know what it's like when it arrives. I really want some rainbow lattice sunstone, but the shipping was restrictively expensive. So I'm going to try and ship it to someone in Australia and get them to bring it over for me if I can manage that.
Nice. I showed it to Jake and he was like, that is the coolest thing that I've ever seen.
I literally went around showing it to fucking everybody and everyone's like, whoa, what is that?
It's just so beautiful. So guys, if you haven't Googled it, please do support the miners. I should have got Jake some for Christmas, but he got something else instead. Speaking of Christmas, this is the last you'll hear from us this side of 2026, which is not to say that we are not available. So we will be back, of course, the 5th of January. I almost said June, I wish. But in the meantime, you can always find us on Instagram or via email. Simon, what are those details?
So it's at Facet Nation Gemmology on Instagram, and our email address is facetnation@facetnation.co.uk. So yeah, stay in touch and we will see you on the other side. And
have a very
happy
Merry Christmas, guys.
holidays to everybody. I hope you have a wonderful break and an excellent new year and get all the gifts that you ever wanted. Hopefully some of them are gemstone shaped and you can show us what you got.
Yeah, send us everything that you guys got that's gemmy or just cool or cat related as well. I'll take those too.
Very much cat related. That's very important.
All right. Well, have a great break, guys, and we will see you in exam season.
See you. Bye.
Bye.